Hello everyone. In this tutorial, we are discussing about GRU, and let's start. What is GRU? GRU basically defines the gated recurrent unit networks. Let's see the definition of GRU. Basically, GRU and RNNs are selectively remember past information using updates. They excel basically handling sequential data by deciding what to forget and what to keep. So this makes them great for tasks like language, speech, and time series analysis. And After that, let's understand that what are the autoencoders. So basically, autoencoders are the neural networks that learn to compress and reconstruct data without labels. They consist of an encoder that squeezes data into a smaller representation that is in latent space, and a decoder that rebuilds the original data. By doing this they discover important patterns in the data. And type basically there are many autoencoders. So the basic and most important autoencoders are there are denoising autoencoders. Basically, denoising autoencoder means they basically learn to clean noisy data by reconstructing the original image by forcing the network to overcome noise. It learns deeper data patterns, preserving it from simply copying the input. And after that, the sparse autoencoder means the sparse autoencoders have more hidden units than inputs, but force only a few to be active at a time. This sparsity is achieved by controlling neuron activations either manually using specific activation functions or by adding a penalty to the loss function. This encourages the network to learn more efficient and meaningful representations. And after that, variational autoencoder. Uh, Variational autoencoder, basically the probabilistic autoencoder. It basically treat latent space as a probability distribution, not just a fixed code. They learn to approximate the true distribution of the data, allowing for better generation and inference. So this probabilistic autoencoder use a technical technique called variational inference to train, making them different from standard autoencoders. And after that, basically the convolutional autoencoders are there, and these convolutional autoencoders are a type of autoencoder that use a convolutional network, I mean the CNNs, as their building blocks. The encoder consists of multiple layers that take a image or a grid as input and pass it through different convolution layers, thus forming a compressed representation of the input. The decoder is the mirror image of the encoder. It deconvolves the compressed representation and tries to reconstruct to the original image. And let's see some example here. So at first as in the previous videos we saw that in every example, or in every single problem, we basically importing at first we basically importing the dependencies. So we basically importing here the matplotlib, numpy, pandas, tensorflow, every and as in every video in previous we saw. So we importing that, and after that basically we train and test this basically uh, this code basically preparing data for a machine learning task, specifically image recognition, where we are using a famous dataset called MNST, which contains handwritten digits, that is 0 to 9. And basically after that we define some basically the step by step representation of this chunk of code, that is the mnst dot load underscore data basically fetches the MNIST data and divides it into training and testing. And we only need the images for xtrain and xstate. The other information is discarded of this part. And preparing the images, after we preparing the images, and images are typically basically represented by numbers between 0 to 255, as we know. To make calculations easier, we change these numbers to be between 0 and 1, and this is called normalization. And this is the normalization formula. So, and after that we checking the shape of the data, and we basically get it. And after that, after that we basically define a class that is simple autoencoder. This chunk of code basically explains that, uh, basically we're defining a new type of model called simple autoencoder. It inherits some features from tf.keras.model. And we specify two important things, that is the size of the compressed data, that is latent dimensions, and the shape of that original data. And after that we build the encoder part. The encoder part takes the input image and compress it into smaller representation. It flattens the image into a long list of numbers, and then uses a layer to reduce this list to a smaller size. And after that, building the decoder part, the decoder takes the compressed data and tries to rebuild the original image. It first expands the compressed data back to the original image size, and then uses an activation function to produce pixel values. And after that, we the call function defines the what happens. Call this call function defines that what happens when we give the model some input, and it sends the input to the encoder, to the then the output of the encoder to the decoder, and the finally returns the reconstructed image. And 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 after that, in the final part, we basically preparing the data, that is preparing data for the model. We figure out that the shape of our images from the test data, and we decided how much to improve, to compress the images, basically that latent dimensions. And we create an instance of our simple autoencoder model using the decided values. So in simpler terms, what we did in this line of in this line of codes. So basically we are creating a machine that can shrink images down to a smaller size and then rebuild them back to look like an original. So we are setting up the parts of this machine and getting ready to use in our image data. So this is an basically after that we basically visualize that. And this problem is something that basically defines some that basically create a image to create down a smaller into a smaller, it turns into a smaller size and then rebuild them back to like look like an original. So basically compression here, right? So yeah, that's it guys. Thank you.